Welcome to the deep dive. Today, we're diving into something pretty terrifying, actually. Imagine looking up and seeing the moon, our constant companion up there, suddenly deciding it's, well, come straight for us.
Yeah, it's a scenario that sources suggest would trigger immediate chaos. Think oceans surging over land, major cities just drowning, the ground itself shaking violently.
Exactly.
And that's really our mission today. We're going to unpack this incredible scenario laid out in the source material. We'll track the consequences over a whole year, starting with tiny changes and ending with, well, utter catastrophe.
And a really surprising fate for the moon itself, apparently.
That's right. It's a journey through scientific predictions, some wild physics, and even a bit of ancient Earth history. It's worth pointing out, though, the sources deliberately slow the moon down for this thought experiment.
Right, because otherwise...
Otherwise, at its actual speed, it hit us in less than 5 days. A year gives us time to really explore the escalating effects.
Okay, let's start the clock. T-minus 365 days. The moon's still way out there. What is it, 384,000 kilometers away?
That's right. Huge distance. You could, line up all the other planets in our solar system between Earth and the moon, and they'd fit.
Wow. So that distance, even if it's heading our way, what's the very first sign? Is it even noticeable?
Probably not much, honestly. The sources suggest maybe slightly higher waves on some beaches. You'd need sensitive instruments to really detect the tiny increase in its gravitational pull at that point.
But that pull is important, isn't it? Even normally.
Oh, fundamentally, the moon's gravity is crucial. It stabilizes Earth's tilt, which is what gives us predictable seasons. Without it, things get weird.
How weird.
Think like the Sahara freezing over for long periods while Canada experiences extreme, unbearable heat waves. It governs our climate more than most people realize. And of course, the tides.
Right, the tides. We see those every day.
Exactly. Earth's gravity keeps the moon locked in orbit, stopping it from flying off, even though it's zipping along at over a kilometer per second. But its gravity pulls back on our oceans.
Okay, let's jump forward. T-minus 300 days. Now it's closer about 250,000 kilometers out. Things must be getting noticeable now.
Oh yeah, very noticeable. The sources predict tides would start surging, maybe up to 5 meters higher than normal.
5 meters? That's huge. What does that do to coastal cities?
It's devastating. Think widespread flooding in places like New York, Miami, London. We're talking buildings damaged, infrastructure completely swamped, massive evacuations needed.
And it's not just the buildings, is it?
No, not at all. Ecologically, it's a disaster. Coastal habitats are destroyed, displacing animals like sea turtles, birds, and a really big problem is saltwater intrusion. Meaning all that ocean water pushes inland and contaminates freshwater sources, rivers, groundwater. Vital drinking water becomes unusable. It's a cascade of problems.
It sounds horrific. Has anything remotely like this ever happened? I mean, not the moon falling, but maybe the moon being much closer?
Actually, yes, in a way. If you look way back into Earth's deep history, the sources point towards the moon's formation itself. The leading theory is the giant impact hypothesis.
Thea.
Exactly, Thea. A Mars-sized object slams into the very young Earth about 4.5 billion years ago. Huge collision.
And the moon formed from the wreckage?
Pretty much. Earth itself kind of reformed, and the debris blasted into orbit, eventually clumped together, coalesced to form the moon.
And the key thing is, it would have been much closer back then.
Much, much closer. And geological evidence actually suggests ancient tides were way higher because of that proximity. We're talking massive tides compared to today.
So Earth has experienced that kind of gravitational pull before?
In its very early history, yes. In fact, the moon is still moving away from us very slowly, about 3.8 centimeters per year.
Which is good news for us now, I guess.
Definitely. That slow drift has no real effect day to day, but it highlights just how dynamic the Earth-Moon system is.
And how do we even know about this Thea impact? It sounds like science fiction.
Well, a big piece of evidence comes from the Apollo missions, the rocks the astronauts brought back.
Yeah.
When scientists analyzed them, they found they were incredibly similar, sometimes chemically identical, to rocks here on Earth. That strongly suggests a shared origin, like they were once part of the same body.
Wow. So pieces of the moon are basically pieces of an ancient Earth?
In a sense, yeah. And interestingly, pieces of the moon still hit Earth today as lunar meteorites. So bits of the moon are already colliding with us, just bite-sized.
Okay, back to the less bite-sized collision. T-minus 200 days, down to T100. Now it's only 100,000 kilometers away. The tides must be insane.
Unimaginable, really. The sources talk about tides reaching 30 meters.
30 meters, that's what's left.
Almost nothing near sea level. Forget coastal cities, they're gone. All the infrastructure we rely on, subways, tunnels, roads near coasts, ports completely destroyed, underwater.
So people would have fled inland, higher ground.
They'd have to. Cities at high elevations like Denver or Calgary, Mexico City, places over 1,000 meters up, they'd be safe from the water. Initially.
Yeah.
What comes next?
The moon's gravity isn't just pulling the oceans anymore. At this proximity, it's exerting tremendous stress on Earth's crust and mantle. It's literally flexing the planet.
Like kneading dough.
Kind of, yeah, but on a planetary scale. And that flexing generates immense friction and pressure deep inside, weakening fault lines, pushing magma upwards.
Earthquakes and volcanoes.
Massive increases in both, globally. The sources specifically mention the Ring of Fire, where most of our planet's volcanoes and earthquakes already happen.
Yeah, around the Pacific.
That area would become hyperactive. Constant violent eruptions and devastating earthquakes shaking the entire planet.
So even if you're safe from the floods, the ground itself becomes treacherous. Exactly. And on top of that, the atmospheric effects. The sources predict a huge spike in extreme weather. Think super hurricanes, incredibly violent storms driven by the altered gravitational forces and the energy being pumped into the system.
It's just total chaos everywhere. Is there anything humanity could do at this point? Any way to stop it?
That's the grim question, isn't it? You might think, well, couldn't we push it away, like NASA did with that asteroid in the DART mission?
Yeah, the double asteroid redirection test, that worked, didn't it?
It did. It successfully nudged an asteroid. It was a proof of concept, really important for future planetary defense against smaller threats.
But the moon...
The moon is just vastly, vastly bigger. And in this scenario, it's already dangerously close and heading right for us, deflecting something that massive, that close. The sources basically say it's impossible with current or foreseeable technology.
So impact is inevitable.
Well, here's where the sources introduce a fascinating twist. It's not necessarily a direct, solid impact. There's something called the Roche limit.
Okay, what's the Roche limit?
It's an invisible boundary around a planet or any large celestial body. For Earth, it's roughly 18,000 kilometers out. If a smaller body, like the moon, held together only by its own gravity, gets closer than that,
What happens?
Earth's gravity becomes overwhelming. The tidal forces, the difference in gravitational pull between the near side and the far side of the moon, becomes stronger than the moon's own gravity holding itself together.
So Earth literally tears it apart.
Exactly. The sources describe the moon rupturing, breaking up into countless fragments, everything from fine dust to huge asteroid-sized chunks of rock.
Wow. So it doesn't hit us whole, it shreds itself first.
Precisely. And those pieces don't just rain down immediately like, say, the asteroid that killed the dinosaurs.
No, what do?
They keep orbiting. They'd spread out, continuing to circle the Earth, forming a spectacular brand new ring system, like Saturn, but made of moon bits.
A ringed Earth. That sounds almost beautiful in a terrifying way. But what does that mean for anyone left alive on the surface?
It's beautiful from afar, maybe, but deadly up close. First, you'd have constant meteor showers. Not pretty shooting stars, but a relentless barrage of rocks, big and small, raining down everywhere.
Okay, constant bombardment. What else?
The ring itself would cause huge problems. It would block out sunlight. Not completely, maybe, but significantly, casting shifting shadows across the planet.
Affecting plant life.
Massively.
Yeah.
Less sunlight means photosynthesis plummets, both on land and, crucially, for phytoplankton in the oceans. And phytoplankton produce a huge chunk of Earth's oxygen.
So the air starts to change. Less oxygen.
Potentially, yes.
Yeah.
A significant drop. And then there's the temperature. Those shadows wouldn't just block light, they'd block heat.
Global cooling.
A serious global cooling event. The sources actually mention a possible prehistoric event, maybe 450 million years ago, potentially linked to a similar dust ring that dropped Earth's temperature by about 8 degrees Celsius.
8 degrees. That would devastate any remaining agriculture, wouldn't it?
Completely wipe out whatever food supply was left after the floods and eruptions. You'd have bombardment, less oxygen, and freezing temperatures.
And communication. Travel.
Gone. Any satellites would be obliterated by the debris field almost immediately. So no global communication, no GPS, contact with any other isolated groups of survivals. Impossible. And space travel, forget it. Earth would be trapped inside its own deadly ring.
It's just one catastrophe after another.
It really is. The sources kind of lay out two worst-case paths.
Yeah.
There's the hypothetical quick impact, everyone dies instantly,
Yeah.
or this slow approach,
Mhm.
The flooding, the quakes, the volcanoes, and then the moon shreds, forms a ring and triggers this slow, grinding extinction through bombardment, cold, and atmospheric
It is
changes.
one better.
I mean, better is a strange word here, right? Both are near total extinction events, but the sources sort of imply the slow disintegration, while horrific, offers a longer, though likely futile period of, well, struggle. Existence, at least.
And that ring wouldn't just settle down quickly.
Oh no. It would take tens, maybe hundreds of thousands of years for all that chaotic debris to eventually settle into a stable, more defined ring system around the equator, like Saturn's. A long, messy process.
Wow. We've definitely been on a pretty catastrophic journey exploring this. It really hammers home the scale of destruction we're talking about.
It does. But it's also crucial to bring it back to reality. Thankfully, as the sources clearly state, this whole scenario is, for all practical purposes, impossible.
Right, because the moon is actually moving away.
Exactly, slowly, steadily moving further out each year. And Earth's gravity holds it firmly in a stable orbit. There's no known mechanism that could just suddenly send it hurtling towards us like this.
So we can sleep soundly tonight.
We absolutely can. Understanding the science, the orbital mechanics, gives us confidence. It helps us separate these fascinating, frankly terrifying what-ifs from genuine risks we might face.
Okay, so for a final thought to leave everyone with, we've talked about two absolutely dreadful endgames here. The quick, maybe painless obliteration of a direct impact versus this drawn-out, agonizing fight for survival under a deadly ring of moon debris. If you had to face one, what would you rather? Something to think about, maybe, as you go about your much safer moon-stable day?